Hello, in this video we're going to go over problem B1 from the 2024 Putnam math competition. So here is the problem. Let n and k be positive integers. The square in the ith row and jth column of an n by n grid contains the number I plus j minus k. For which values of n and k is it possible to select n squares from this grid, no two in the same row or column, such that the numbers contained in the selected squares are exactly 1 through n. Okay, so the first thing that I thought was that let's say the cells are at the positions I1, J1 all the way to IN, JN. What we know is that these are not in the same column and not in the same row, which means the row indices and the column indices are all the same as 1 through n. But we also know that I1 plus J1 minus k all the way to In plus Jn minus k would also have to be the same as 1, 2, all the way to n, which clearly tells us that there's got to be a relation between k and n. Well, to get that relation, let's add up all of these numbers. So we get I1 plus J1 minus k plus In plus Jn minus k. That would have to be the sum of 1 through n. But what we know is that this is another permutation of 1 through n. In other words, I1 through In would have to be 1 through n, and also J1 through Jn would have to add up to the same sum of 1 through n. So now that allows us to kind of get rid of this sum, so I1 through In, and this sum cancels, and replace the sum of the j's with n times n plus 1 over 2, which is the sum of the numbers from integers from 1 through n. So this minus nk would have to be 0, which means k would have to be n plus 1 over 2. And in order for this to be an integer, we need n to be odd. So we have two conditions. First, n is odd, and second, k is n plus 1 over 2. So these are the conditions that are necessary for us to have such a situation. Now, let's try different values of n and see if there is a pattern that we can in fact come up with these cells that are a permutation of 1 through n. Let's start with n equals 3. So we're going to get a 3 by 3 grid, and let's place the numbers. So k becomes n plus 1 over 2, which is 2. So the first cell on the top left corner would be 1 plus 1 minus 2, so that's 0. And then once we go to the right, we are going to increase this number. And once we go down, we are also going to increase the number. So 1, 2, 3, 2, 3, and 4. So these are the numbers in the cells. And by a bit of inspection, we'll see that there's a pattern here that gives us, in fact, all the numbers from 1 through 3. If you try n equals 5, k would be the average of n and 1, which is 6 over 2, which is 3. And once we look at the grid, we're going to be able to create that pattern in a very similar fashion. So we have the 5 by 5 grid. So 2, 3, 4, and 5. So we take 1 plus 1, which is 2 minus 3. So that's negative 1, 0, 1, 2, 3, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, and etc. So we can fill in all of the cells of this grid. And again, by some inspection, we'll see that this is going to work. So now once I got to that, I realized that there's actually a pattern here. So it looks like I have to start from the middle cell in the first row and then go diagonally and then move down and do the diagonal again in this sub-square right here. So I'll do a diagonal here, and then I'll do a diagonal here, and that looks like that gives me all the numbers from 1 through n. So suppose n is odd and k is n plus 1 over 2. So now we're going to consider these cells. Consider the cells. So we look at the first row, and in the middle of the first row, so it is the cells located at 1 n plus 1 over 2. So this is the first row, and the column n plus 1 over 2, 2, and we're going to move 1 to the right, so n plus 3 over 2, all the way to, so this one is also again the middle row, so it would be n plus 1 over 2, and we are adding n plus 1 over 2 to n plus 1 over 2, and we are subtracting 1. So these are n plus 1 over 2 cells. Now these cells, the numbers, the corresponding numbers are the corresponding numbers are, well, we take I plus, for every I between 1 and n plus 1 over 2, we take I and n plus 1 over 2 plus I. This is the position of each of these, but we have to subtract 1. So this is the row number, this is the column number, and then we have to subtract k, which is n plus 1 over 2. So this would give us 2i minus 1. And I ranges from 1 to n plus 1 over 2. So this gives us all the numbers from 1 to n, except that only that are odd. So these are the numbers between 1 and n that are odd. Now we're going to move down and look at the other cells. So consider the cells so we have to look at the ones starting from the next row, but the first column. So the next row would be n plus 3 over 2, and the first column all the way to, it would be the nth row, and the column number would be n minus 1 over 2. So these cells. Now, what are these cells? Let's say the numbers are, in these cells, the numbers are, so we have n plus 1 over 2 plus I, and then plus another I, and then minus n plus 1 over 2. So this is the row number, this is the column number, this is the column number, this is the row number, and this is our k, which gives us 2i, and this I ranges from 1 all the way to n minus 1 over 2. So this gives us all the even numbers from 2 all the way to n minus 1. So we had all the odd numbers before, now we created all the even numbers, therefore we get all of the numbers from 1 through n in these cells. And that brings me to the end of this video. So I will see you in the next video.